Hello, this video will cover programming a Raspberry Pi using Simulink. This is the web page that you can Google for to download the support package. The process will install the package in the existing Matlab Simulink environment, and a configured Raspbian is flashed on a microSD card, as shown if you click on this link. Upon booting the Pi with this card, Matlab will communicate via a single Ethernet cable, in my case, but there is an option for the Raspberry Pi to be connected via an existing network. This demo is a proof of concept on using a popular ultrasonic module. It has a transmitter and a receiver. Operation is simple. When a trigger pulse is sent to it, the transmitter generates a sonic burst, and the receiver is listening for the return signal or echo. Once the reflected burst is received, the echo pin outputs a TTL level pulse with a duration proportional to the distance of the reflecting object. This diagram shows the logic of the implementation. Here is the ultrasonic module powered with 5 volts. The trigger input, which we will drive with a 10 microsecond pulse every 3 seconds, coming from pulse generator 1. The echo output will go to one input of an AND logic gate, and its second input will be driven by another pulse generator or generator 2. This timing diagram shows what is going on at the AND gate. For as long as input A stays on the high logic level, the output just follows the signal entering input B. In other words, the echo pulse enables the pulses from generator 2 to go out. The counter will accumulate the number of pulses coming out from the AND gate, and the value will be sent out of the Raspberry via the network cable using a UDP protocol. The hardware implementation on the Raspberry Pi is shown here. On the right is a representation of the GPIO connector on a Raspberry Pi Model B. Then VCC is taken out from pin 2 as the ultrasonic module uses 5 volts. For the trigger output, we are using GPIO 17. For the echo input, we must perform a level shift as GPIO is using 3.3 volts and the output of the module is TTL level or 5 volts. We use a simple resistive divisor to drive over GPIO 4, which is an input. I am also using GPIO 27 as a monitor pin. This is not necessary for the demo. It is just for verification or debugging purposes to check the output of the generator 2 with an oscilloscope. Okay, let's start with Matlab. Then we go to the Simulink library, and that will open the block browser. They are grouped by different applications. Then we create a new model. This is opening a canvas that we will start to fill with the modules building our model. From the sources, we will get the pulse generators. Then we will need the modules in the Raspberry Pi group. Over there, we will look for the GPIO read or input, the GPIO write. We are taking 2 of them. And finally, we need the UDP send block. We continue with the AND gate that we can get from the logic and bit operators. Here is our AND gate. Then we need our counter, and we will check this one here. We will also need a convert module for the connecting the pulse generator to GPIOs. For some reason, the output of the pulse generator is not directly compatible with the GPIO input. That's why we use the convert. Now we work on these modules. We do all the interconnections. This is just a matter of putting that in a neat way so it's easy to follow and understand. Here is our AND, here the convert. This is the output just for monitoring, for debugging purposes. Configure the counter. Let's make it 8 bits. Just count. No reset input. So here it is, only input and output. Let's complete the connections. The counter will go all the way up to 255 and start over from 0. Now everything is connected. Let's continue doing the configuration. The amplitude of the pulse 3 volts. The period, we will set it in 0.1, and the pulse width will be 0.01. Let's continue with the GPIO input. It's pin 4, and sample time 25 microseconds. Let's apply. For this block, we need to change the output pin to 27. 17 is in use for the trigger. For the pulse generator, we use 3 volts and then 50 microseconds period with a 50% width. Finally, the UDP block is pre-configured for broadcasting, but let's put the IP address of the laptop. This is the port. Apply and OK. So we are now all the modules configured, and we will save the model with some name we remember, Ultrasonic 1, save. And now everything is ready to run, but remember, I didn't define the hardware yet. So we go to Tools and Prepare to Run. Now the target hardware, we pick the Raspberry Pi. We can see the IP address, home folder, and TCP IP port for communication with Matlab. By clicking on this icon, Deploy to Hardware, Matlab is now sending all the source files to the Raspberry Pi home directory and start the building to then continue with the execution on the target. Now the building process is complete and the model is running on the Raspberry Pi. If we open Wireshark, we can see that we have UDP packets coming from the Raspberry Pi. We can see also that the data is changing. Let's close this one. Let me open a Simulink model that I have with built-in UDP receiver. You can see the IP port, 25,000, and the IP address of the Raspberry Pi. So click OK. Let's open the scope. If we run this model in the laptop, we can see that now we have a display of the UDP package coming from the Raspberry Pi. If you see the increment is every approximately 3 seconds, which is when I'm triggering. And now this is pointing to a wall, so it's a constant distance. If I aim the module to a different point, we can see the change on the count value. We do not need a Simulink model to display the data. I also use a Python script on a Linux machine. Here I have a scrolling display, very similar to the scope module in Simulink. Okay, I'm almost done. Let me show the components used in this project. Here is the ultrasonic module, and then it's connected to the Raspberry Pi, and here is the monitor. So let's look at the terminal on the Pi. This is the home directory where all the projects are residing. If we change directory to our project, we can see that all the files are there. The source code in C, the object files are there. Also, there is a directory called MWU. If I change to that directory, I can see that there is where the binary file is residing. Right now the model is not running, as we can see on the UDP display. If I now use sudo, because it's a GPIO, requires the super user, and we run the binary file, the model is now started, and we can see now the UDP receiver is getting all the packets. If I now go back to the terminal and hit Control-C, the project is stopped, and as we can see, there is nothing on the UDP display. I hope this video has provided enough information to get you started with Matlab Simulink on Raspberry Pi hardware. Thank you very much for watching.